So cool guys, in this session we are going to discuss the Codeforces round 861 that was ready for Div.2. So we'll be going over the problems A, B and C. So let's get started with the very first problem. This is definitely easy. So the problem states that Olympus City recently launched the production of personal starships. Now every one on Mars, blah blah blah, basically a pretty long statement. But what they want us to do is that they'll be providing us two numbers. So we should consider the first number as left limit, the next number as the right limit, and we need to tell them what is the best number in these. Now the definition of best number is that the difference between its maximum and the minimum element, right? Or the maximum and the minimum digit in that particular number is maximum. For example, in case of 59 to 63, we have the numbers 59, 60, 61, 62, 63, right? So in this 59 has the value, the maximum number over here is 9, the minimum is 5, so it has the value 9 minus 5 is equal to 4. Similarly, 60 has 6 minus 0, 6, 61 has 6 minus 1, 5, it has 4, it has 3, so on. So yeah, that is what they want us to find. Now the only thing is that let's look at the constraint. So this is pretty easy to do, right? If I ask you to do it, you will always be able to do it. It's not a hard thing. The problem is that over here, L and R can go up to 10 to power 6. So we cannot definitely give a brute force solution. It's going to give it TLE because 10 to power 6 is still fine, but the number of test cases are also 10 to power 4. So that collectively becomes 10 to power 10, which definitely cannot get passed. So the important observation over here was that the answer, max answer can always be 9. What I mean by that is that the maximum digit cannot exceed 9, right? And the minimum digit cannot exceed 0. So the answer maximum would be 9 itself. Corresponding to 9, the answer could be something else, like it could be 90136. Over here, the result, the score it gives us is 9 itself, right? So the number could be different, but the max value is this. Now, if your A minus B, right? If the difference between B minus A, not A minus B, but B minus A, because B is the greater one, if it's greater than or equal to some value, let's say, if it's greater than or equal to 100, what would happen in that case? If it's greater than or equal to 100, then the answer is always 9. How can I even say that? Now what would happen is that let's say you have a value 0, right? Not 0, but because that's a very base case. Let's take example 29, right? So you'll go from 29 to 99 or to 90, right? And then you'll say that, okay, this is the best value. Would this always repeat? Yes, it's bound to repeat. The reason being that you just need 9 to be a 09 or a 90, right? In your answer, whatever the previous values are, you just need this sequence, right? And in order to get this sequence repeated from 09 to 90, they are just 81 values, right? And similarly from 90 to 09, they are just 19 values. So if the difference between your B and A is greater than or equal to this, then the answer would always come, right? The answer would always be 9. Okay, it's greater than or equal to 81 because we're going to take the maximum of these two values, right? But in order to avoid checking all of this stuff, what we can do is we can brute force it from I is equal to A to I is less than equal to B, right? And at each step we'll calculate the result, and then we can manually check that if our result has already become 9, then we can quit over that and we already have the answers. So that's what I have done in this. Any doubts? Guys, keep your mic mute unless you don't have a doubt. Okay, so let's look at the solution. So this is the solution, I guess. 1080. Wait. Yeah. Okay, so over here I'm just taking two values A and B, and then I'm iterating over all the values. Then I'm checking that what's my result. So for that I used a function. So my result is basically the maximum element minus the minimum element, right? At any point, if I have a result 9, I know that I have already received the best result. So let's quit, right? And if it's not 9, but it's something better than I already had, then take that. At the end, if the result didn't reach 9, but it was some other value, you need to print that also. So you print it over here. Cool. I hope that no one has a doubt in this particular question. Let's move ahead to problem B if someone has a doubt over that. Okay, so problem B is playing in a casino. So problem B states that Galaxy luck, blah, 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 basically a very long statement over here or two. But what they want us to do is that there are n players and they have m cards, right? So n players have m cards and the cards are rated from 1 to m, right? After that, they play some games. Now, who plays with who? Everyone plays with every other person, right? Or you can say that whenever two. So basically, everyone. Okay, let me tell you what I mean. Yeah, you can assume that everyone plays with every other person, right? So what would happen is that, let's say two people are playing. One has these cards and the other has these cards, right? Now we are not concerned who wins amongst them. We just want to tell that what would be the addition to the score. Addition to the score would be uh, absolute value of 1 minus 7 plus absolute value of 4 minus 9 plus absolute value of 2 minus 2 plus absolute value of 8 minus 1 and then plus absolute value of 5 minus 4, right? Now a naive approach would be to calculate all the possible permutations, and that can work. However, it would take you n into n minus 1 by 2. That is basically order of n square time complexity. Even to make the matter worse, is actually gonna be order of sorry, not of order of n square, but order of n square m. So you're gonna check for all the possible permutations or all the possible groupings in which players would play, and that is actually order of n square. For all of these groupings, you will check for all these m elements. So it's gonna become order of n square into m. That's gonna give you TLE. So what other thing can we do? So let me share my screen. Yeah. Over here, the important or easy observation is that, let's say these are the numbers, these are the players, right? So let's say this is the player 1, this is the player 2, this was P1, this was P2, this is P3, right? And let's say it had element A, B, C, D, E, F, G, H, I, J. Just populating some random gibberish over here. Just wanted to make you understand. Now what would happen is that when P1 would play with P2, its answer is A minus F plus B minus G plus C minus H plus so on, right? Similarly, when A would play with L, or 1 would play with 3, its answer would be A minus L plus B minus M plus C minus H, so on, right? This is the absolute values, right? Now easily you can observe that what would be the result of A minus F, or what would be the result of A minus F taken the absolute value. So when you take the absolute value, you get a positive result. So that means if A is greater than F, right, then it becomes A minus F. But if F is greater than A, in that case it becomes F minus A. You can use this observation to plot your answer. So you can say for each of these m indices, right, these are the m indices you are having, right? These are m. Okay, yeah. For each of these m indices, I'll take the cards of each player and then I'll sort them. So you'll be over here you'll be getting A, F, L. That would be one set. Then you'll be having B, okay, G, M. That would be the other set. Then you'll be having something like C, H, N, then D, I, O, so on and so forth, right? Now for each of the element when they are sorted, so let's say A, H, L, right? Now you know that A is less than H is less than L because they're already sorted. So what you'll say is that H is definitely greater than A. So what would be its contribution? So when we'll be having a game with A and H, right? So H is gonna win. Now since H is gonna win, we have to add H, right? So 1 into H plus when H would be having a game with L, it's gonna lose. So for that we have to subtract H, subtract L. But this was the case wherein the only 3 elements are here. Now it's possible that there are multiple elements over here, right? So in that case, we'll say the number of elements that are to the left of H, right? So let's call this L, or let's just give them a different thing. So let's call them L dash. Let's call this R dash. The number of elements to the left of H are L dash. The number of elements to the right of H are R dash, right? So the contribution of H would be whenever it's gonna play with the elements to the left of it, it means H is greater than them, right? So in that case, the contribution would be L dash into H. But whenever it will play with the elements to the right of it, right, then it's gonna get subtracted. So that contribution would be minus R dash into H. For all of these numbers, if we compute this, so this would be get computed in order of nm, order of n into m, and we'll finally have the answers. Any doubts in this? Because it's just maths, it's just simple maths. If there are no doubts in this, I can discuss the solution also. Any doubts? Cool, I'm assuming there are no doubts. I'm proceeding ahead. But if anyone has any doubt, you can speak right away. Okay. Yeah, this is the problem solution to the problem B. So what I'm doing is, firstly, I'm taking the input. After that, I'm populating the sets as I said, right? So for all of these, like going from this j from 0 to m, I'll keep the ith or I'll keep the jth card in a certain set. So I'll keep the jth card in the jth set. Cool. After that, I'll sort them because I want the values in non-decreasing order. After that, I'll say that if I'm at the jth index, that means, okay, if I'm at the jth index, okay, so this is jth set, and in the jth set, there would be n cards, right? Because there were n players and n players had one card each in each of the sets. So in the jth set, there would be n cards. Standing at a position I, there are I cards that are less than you, right? And there are n minus 1 minus I cards that are more than you. So you'll simply say that my contribution or my value into the number of cards that are less than me, that will get added, and the cards that are greater than me, or the number of cards that are greater than me, that is n minus I minus 1 into my value, that would be subtracted, and this would form your answer. So you'll have to add it to your answer, at the end just print the result. That was it for B. Let's yeah, any doubts? Codeforces mic is on. You can turn it off if you don't have a doubt. Okay, let's move on to C then. So C is based on digit DP. I'm already telling you that. If you haven't watched a video which we had on digit DP, so I'll suggest you to watch that. If and if you're like, if this video is already uploaded and you're watching this video, I'll probably put a comment in the comment section mentioning that video. Anyway, so the problem states that unlucky numbers. So in this problem, the unlucky number, in this problem, unlike problem A, you need to look for the unluckiest number. So in the problem A, if you remember the problem which we solved earlier, we were trying to look for the luckiest number, right? The luckiest number was such wherein the difference between the two numbers is maximized. So for example, we were saying that, okay, if the difference between the two numbers is greater than 100, then we'll always be having an answer. But that is not the case over here. So over here, we have to minimize the answer. Now that becomes a problem. So how would we even do that? So a few observation over here is that since it's going like L and R are going up to 10 to power 18, there's no way to brute force this. The other observation is, if the size of L and R are different, that is the left number and the right number are different, in that case, your answer is always 0. So how can I say that? Give me a second. Okay. So if your variables L and R, that is the left limit and the right limit, if their size are different, so that basically would mean that your R would be something like say 1000 and your L is something like 9000, right? But as soon as you transit from this state to this state, the last number you'll always have is 9999. No matter what your L was and what your R was, there could be any value, but when you transit or when you increase the size of a number, the last state is always a permutation of 9s, right? Because you have a permutation of 9s now, so you can say this is your answer, because over here the maximum and the minimum number is actually 9 itself. So your answer also becomes this, right? Answer is equal, so the difference becomes 0 and the answer, this is always a valid answer. So that could be a base case. I've also used that base case. So I've said that, okay, over here, if my size are not equal, that will basically mean that the size of B was greater because A is less than B, obviously. So if that is the case, then the answer is all just a permutation of 9s, right? And then I'll return. But if that does not happen, so then I'll have to test for the best answer possible. Now, how would I do that? Now, although over here, like L and R can go up to 10 to power 18, right? Yeah. But even in 10 to power 18, there are just 18 indices, or there are just 18 digits. So I can traverse over these digits. And that basically is called digit DP. When you're traversing over the digits and you're saving the states, that is what digit DP is, right? So let's have a look. How do we even do that? But the only problem over here in this particular problem and the generic digit DP problem is that when you are given a digit DP, so generally you are asked that how many numbers lie in this range L to R that satisfies some constraint, right? So in order to calculate that, you can call your recursive function for R, and then you can subtract the value from L, and then you'll be having your value. The problem over here is it's not asking us that how many numbers are there or something of that sort. That kind of a question is not being asked. So that changes the scenario, because now you will have to handle the cases, right? So whenever you are building a number from left to right, so in your decimal representation or any representation format that matter, the leftmost number, or more the number is towards its left, the more is its value, right? Now let's say your L was maybe like 123, just giving it a random value, and R was 826. Now if you change this in the current number that you are forming, if you change this value to 2, right, then no matter what values you place at the indices 1 and index 2, it is always and always going to be greater than L, because we already assigned it a value that was greater than 1, that was 2, right? So it's always going to be greater than L. Also, we'll let's check it for R. So also for R, you assigned it a value that is less than this particular index, or it's less than the element at this particular index. Since you did that, hence we can also say that whatever value you're gonna put over here or over here, so yeah, over here or over here, they're always and always be gonna lie in the range from L to R, right? So what are the 4 cases that arise out of here? So as soon as you put any number at this point, right? So at a place IDX, if you put a number, if that number is greater than whatever your result for IDX was, or whatever your left of IDX was, if it's greater than that, then for the remaining strings or remaining digits, you can put any number, and it's always gonna be greater than left. And the other scenario is if this number at IDX is lesser than right of IDX, or the upper limit you are having, if it's lesser than that, then you already have minimized this number, and whatever numbers you put, whatever digits you put in this range are always going to be such that the number remains smaller than the right limit. So this is the crucial observation, and this is the point at which we'll be forming a solution. Any doubts in this? Guys, any doubts so far in this? Feels like you can explain the contribution part again, as we are taking absolute in each case. Sure, Fallon. So yeah, cool. Give me a minute. I'll explain that. So what absolute pass basically means, that when you're doing A minus B, right? So what happens is that if A is greater than B, the absolute become or if I want to take out the absolute, if I want to cancel the absolute and still get the right values. So if A is greater than B, I can write this particular equation as this. But if A is less than B, then I can write this particular equation as B minus A. Right? For example, if A was 3 and B was 5, so in this case, the absolute of 3 minus 5 would give me 2. Right? Now, if 3 is less than 5, so that means this particular case, in this case, we could have done simply 5 minus 3, and we would still have got the answer 2. This is what I meant by that. Make sense, Fallon? Okay, I muted you earlier. Probably your mic was on something. Yeah. Fallon, that's fine now? Okay, I'm assuming it.
Yes.
Okay, cool. Okay. Anyway, Fallon, just like there's a background noise at your end, so please keep that mic off. Okay, so hope this logic is clear. Is there any doubts in this particular logic? Because this is the entire fundamental or the entire concept that we are going to use. Okay, cool. Let's move ahead then. So that's what I'm going to use. So let's call 2 variables that is a greater than the beginning, or it's smaller than the end, smaller than x or greater than big. That's what we are using, and that's what I already explained, right? Now, what could be the scenarios if you have already reached the end? So this is the terminating condition. This is the terminating condition. So this is different. What are other things? Let's avoid this for that matter. We'll study about states later, but let's talk about the heart of the question and how it's processing it. So I'll say if the number, if it's not even greater than the bigger, or if it's not greater than the beginning, and if it's not smaller than the mx, then the digit I can put at this particular index needs to be in this range. That is the beginning and the limit, or the L and R. It has to be in that range. So I'll put only the elements that are in that range onto my number. Also, while calling this function recursively, I'll have to check that it's possible that initially it was not greater than the beginning, or not greater than L. But now when I put this particular character, this particular character could be greater, or this particular number can be greater at the number that was available in the L, right? So I'll have to check for those cases. So I'll say that if I was okay over here, if I is greater than beginning IDX, or if it's greater than the character at the beginning, right? In that case, it's this value becomes true, right? So I'll have to pass this. Also, the other case is that when you're passing a value over here, now let's say you had L as 1 2 3, you had R as maybe 5 6 7, and currently you are passing some numbers. The right part of the number is not known, but the first number is let's say 1, right? So definitely it's not smaller than the beginning, because even in the beginning the number was 1. Over here you're also having the number 1, but it's small. Sorry, not it's not greater than the beginning. It cannot be smaller, but it's not greater than the beginning, because at both the places you are having a number 1. However, it's smaller than the right limit. In the right limit, you are supposed to have a number 5, and over here you're putting a number 1, so it's definitely smaller, right? So you're gonna check if the number is smaller than the limit you're having, then this would become true. That would mean this particular parameter would become true. Now, what are the other cases? Since we are having two variables, there can be 4 cases, 2 to the power 2. So one case was 0 0, that is it was neither greater than the left and nor less than the right. The other condition is that it can be greater than the left but not less than right. So in that case, since it's not less than right, cool. So you cannot have a value that is exceeding the right limit, but you can have any smaller values over here, because being smaller than the left has already been accomplished before. So you'll say that if this is the scenario, then you can go from 0 to limit. Cool. The rest of the operations actually remain same in each of these 4 cases. There are better ways of doing this, but this is what came to mind, so I coded it up here. But definitely you can do it in a single loop rather than putting 4 if-else statements. Cool. What's the other case? The other case is that it could be the scenario that it's smaller than the right limit, but it's still not greater than the left limit. In that case, the number at this particular index would be greater than whatever the number greater than or equal to whatever the number is there in your limit, right? Or in the left number, and it needs to be smaller than or equal to 9, because that's always the biggest number you can have in a digit. Cool. So we'll do that. Right. And what is the last scenario? So it's all the last scenario is that it's smaller than the left limit. Oh, sorry, it's greater than the left limit and it's smaller than the right limit. In that kind of a scenario, whatever number you may put, the number is always going to be in that range we require. Cool. So if that's the case, we can try for all the values from 0 to 9. Now, if we proceed in this way, then it's going to check every permutation, right? And it's going to give you a TLE. So now let's define some states that we can use. So what are the values that actually matter? So the MX value definitely matters, because that's going to define your result, right? So why I'm saying that? So let's say your number was 1, 2, 3, 4, some more digits like this, and then a 9, right? And this entire number, I don't care whatever these digits are, because the minimum and the maximum number are 1 and 9, and that is what is going to decide my result. So all of these numbers are meaningless to me. The only number I'll be interested in would be 9 and 1, because they are the maximum and minimum values I'm having. So let's use that. So I'll be using that over here. So I'll be using that a number mx, a number mn. Then I'll be saying it's greater than the beginning, or it's smaller than the maximum. Yeah, variable names definitely can be improved over here. This is a lot shitty nomenclature, but anyway. So and the other thing is IDX. So which particular index you are at. These are the only things that are required. Also, looking at the constraints that provided, so these are Boolean variables, so they can only have 2 states, 0 and 1. So that's fine. What about mx and mn? So these are digits. They can go from 0 to 9. That's also fine. What about IDX? So IDX can go up to 10 to power 18. That is basically 19. That basically means 18 digits in total. All of this is fine to me. I actually gave it a bit more memory. You can actually go with this. So you can go over 18 over here, 10 over here, and 10 over here. Yeah. So these are the things that are given to me. Let's try to construct a DP out of it. So what this represents mx, this represents mn, this represents idx, this represents greater than big, and this represents smaller than max, right? We'll use that. Now we'll say that if you have already visited it, so it's a boolean dp, we just want to check if you have already visited this kind of a combination or not. So we'll say if you have already visited this kind of combination, then return, right? If you haven't visited this kind of a combination, just mark it as 1. That's it. So that's it what the question requires. And what would happen is that at some point in time, if you reach a point that is after the last element, so that means you have already constructed your entire string cur. Now you need to check if this has a better answer than all the answers you already have, right? So all the answers you or the answer or the best answer you already had, its corresponding difference would be stored over here, right? I'll check if the difference is greater than mx minus mn. In that case, I would like to assign the difference to diff, right? And I'll update my result with cur, and then I'll return. So yeah, that's it. Initially, you have to provide or you have to initialize the dummy vector, not the dummy, but the DP vectors. So initialize it with zeros, right? Because initially you have not visited any kind of states. Initialize difference is 10 because the maximum difference can be 9. So we wanted to provide it with a dummy value. So let's provide it with 10. You can provide any other number as well. And let's provide rest num with a. And then you make this recursive call. Once this recursive call is completed, you will obviously be having your answer in rest num, that is this particular variable. So you print out that. Cool. So that was it for this problem. Any doubts? Yeah, Beast, this would be uploaded. For this question, no, bro. I don't have any sort of idea how we can use binary search over here. I even saw the binary search tag on problem D, but definitely no idea how they are using binary search. Because like binary search is fine for me. I'm able to do a lot of questions with binary search, but this time I have no clue. But for A, even if you are able to do it with binary search and you know that an order of one answer actually exists, why would you even do that? Doesn't make sense, right? Cool. Any doubts now, or I'll close this meet. Let's unmute him. Cool. Cool, guys. Bye bye.